double angle and half angle formulas. For this lesson, one of the things that we'll be using is the unit circle. So you need to have a unit circle in front of you. And also, for the first part of the lesson, the double angle identities are here in this box. And you can see that there are formulas for sine, cosine, and tangent, and that the cosine formula and the tangent formula actually have some choices. And so I'll talk about that as we go along. And we're going to use these for some specific types of problems. The first one is we have a triangle that's been labeled with the measurements of the sides, and then I've labeled the opposite side, adjacent side, and hypotenuse. And the way you know what's what is you have to go by the angle that's been provided. Either you've been given the measurement of the angle or it's been labeled with a variable. So since this theta is the angle I've been given when I travel across the triangle, that makes the 5 the hypotenuse, not the hypotenuse, sorry, the opposite, and 12 the adjacent. The hypotenuse is always opposite the right angle. So we're going to need SOHCAHTOA to do some of these problems. Remember that stands for the sine is the opposite over the hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. We're asked to find the cosine of 2 theta. And the cosine of 2 theta formula has 3 different options, and you can pick whichever one you want to. And since I have all 3 sides of the triangle, it would be easy to use both sine and cosine. I'm going to use the formula that says cosine 2 theta equals cosine squared theta minus sine squared theta. And because of the triangle, I can figure out the values for sine and cosine. Cosine is the adjacent over the hypotenuse, so that would be 12 over 13. The sine is the opposite over the hypotenuse, which is 5 over 13. So when I fill those values into the formula, we'll have 12 thirteenths squared minus 5 thirteenths squared, which is 144 over 169 minus 25 over 169, and that comes out to be 119 over 169. Using that same triangle again, this time we're asked to find the sine of 2 theta. And there's just one formula for that in our identities, and sine 2 theta is equal to 2 cosine theta sine theta. And from the previous problem, we've already figured out that cosine theta is 12 over 13, and sine theta is 5 over 13. So filling in the formula, we have, and that will go with the cosine, that will go with the sine, we have 2 times 12 thirteenths times 5 thirteenths, which is 120 over 169. For this triangle, there are different measurements, and we have been given a little alpha this time instead of a theta. And so based on where this angle has been labeled, if I travel all the way across, that makes 8. The opposite side, and we've been given the hypotenuse, but we don't have the adjacent side. So we're going to have to find that, because if we're using tangent, we need to know the opposite and the adjacent. We'll do Pythagorean theorem. A squared plus b squared equals c squared. Remember, c is always the hypotenuse. So that will be 8 squared plus b squared equals 17 squared. 64 plus b squared is 289. Subtract 64. B squared is 225. And then square root both sides. B is 15. So the adjacent side is 15. The formula for the tangent of 2 theta, we need to know the value for tangent. So the tangent of just regular alpha is opposite over adjacent, 8 over 15. Now we can fill in the formula. So the formula for the tangent of 2 alpha, or theta, doesn't matter, is 2 tangent alpha over 1 minus tangent squared alpha. And so the 8/15 will go everywhere we see tangent. 2 times 8/15 over 1 minus 8/15 squared. On the top then, 2 times 8/15 is 16/15. On the bottom, that's going to be 1 minus 64 over 225. On the bottom, I'm subtracting fractions, so I need a common denominator. It would be 225. And if I put it on the bottom, I have to also put it on the top. So I've got 16/15 over, and 225 minus 64 is 161 over 225. Remember, a fraction bar means divide, so I can unstack these fractions and write it 16/15 divided by 161 over 225. The top fraction divided by the bottom fraction. And the rule when you divide fractions is you flip the second one and multiply. So that would be 16/15 times 225 over 161. When I multiply tops and multiply bottoms, it's 3600 over 2415, and that reduces down. I believe they both divide by, actually I'm not real sure. I didn't write that down. But it reduces down to 240 over 161. So those are double angle identities. Now let's look at half angle identities. So there's one for sine, cosine, and tangent. Notice there's a plus minus in front of each square root in the formulas. It depends on the quadrant of your original angle, whether you'll use the plus or the minus. So the plus or minus depends on the quadrant of the original, and that's important, angle. So I've drawn a circle here that has, that's supposed to be the unit circle, and I just labeled the left, right, up, and down degrees on that. And the circle is split into 4 quadrants, and they go counterclockwise. And you can see what functions are positive or negative within those quadrants. Also, if you use the unit circle that I had at the beginning of the lesson, what's positive and negative in each quadrant is also given. So we want to use a half angle formula to find the exact value of the tangent of 75 degrees. 75 degrees is not on the unit circle, so we need another method to find its value. First, we need to know, as far as the formula goes, if it's supposed to be a plus or a minus in front of the square root. So I look at the angle that I've been given, 75 degrees. That's in quadrant 1. And the tangent in quadrant 1 is positive. So I know I have a positive square root. Now the formula has, after you have your angle, it says tangent of theta over 2. So for these two things to be equal, for theta divided by 2 to equal 75, theta has to be 150, because 150 divided by 2 is 75. So basically, to find the value that you need for theta, you double the given angle, which is kind of confusing because it's called a half angle formula. So you double the angle you've been given, and that's theta. So we have the tangent of 150 over 2. And then in the formula, everywhere we see a theta, we're going to replace it with 150. So I know it's positive, which you don't have to really write a plus. And then the formula for tangent is square root of 1 minus cosine theta, which is 150, over 1 plus cosine theta. Then you're going to use the unit circle to look up the value of the cosine of 150. And it is negative square root of 2 over 2. Cosine of 150 is negative square root of, not 2 over 2, 3 over 2. So I'm going to put that everywhere I see cosine of 150. And we'll have big square root, and then underneath, 1 minus a minus turns into a plus, square root of 3 over 2, over 1, and then it's a minus square root of 3 over 2. And then that could be simplified somewhat. You could get the fractions together and simplify the square roots a little bit, but we're just going to leave it right there. So you double the given angle, and that is theta everywhere in the formula. Let's try. The sine of 15 degrees. 15 degrees is in quadrant 1, and the sine in quadrant 1 is positive. So get that taken care of first thing. And now I need to double the 15, which is 30, and put it over 2. So everywhere in the formula I see a theta, we'll replace it with a 30. The formula for sine is, and again it's positive, square root, and the top is 1 minus cosine theta, which is 30, over 2. And then on the circle, I look up the cosine of 30, and it's square root of 3 over 2. So I end up with big square root, and then 1 minus square root of 3 over 2, all over 2. Let's try the cosine of 112.5 degrees. 112.5 would fall in quadrant 2. And in quadrant 2, the cosine is negative. We double the 112.5, so cosine of 112.5 equals cosine of, and if you double 112.5, you get 225 over 2. So everywhere I see a theta in the cosine formula, I'll put 225. So it's negative square root of 1 plus the cosine of 225 over 2 equals negative square root of, and when I look up on the circle, the cosine of 225 is negative square root of 2 over 2 over 2.